Fire. You've witnessed it countless times. Birthday candles, gas stoves, bonfires. Striking a lighter brings flames to life instantly. But have you ever stopped to ask, why? Most people never question it. Fire simply exists. It's hot, it's bright, it consumes things. End of story, right? Absolutely wrong. When you truly examine what fire is, when you investigate what's genuinely occurring during combustion, you uncover something so elegant, so fundamentally interconnected with nature's fabric, that it transforms your perception of reality. Fire isn't merely a phenomenon. Fire is a gateway to understanding atomic behavior, energy transfer, solar power, and the very reason forests blanket our planet. Let me reveal this to you. Picture a log, dead timber just sitting there, completely inert. And air, oxygen molecules drifting around, equally inactive. The wood has been there for days, months, maybe years. The oxygen has surrounded it the entire time. Yet nothing happens. They simply coexist. But here's what's fascinating. At the atomic level, these particles are attracted to each other. Carbon atoms in the wood and oxygen molecules in the air would actually prefer to bond together. When they successfully connect, they lock together firmly. This bonded state releases tremendous energy. It's the stable configuration, the lowest energy arrangement possible. So why aren't they bonding right now? There's an obstacle, an energy barrier. Imagine rolling a marble along flat ground toward a deep crater, like a volcanic pit. The marble would love to drop into that low-energy hole, but there's a ridge surrounding it. The marble approaches, starts climbing the ridge, then rolls backward. It never gets close enough to fall in. Unless you give it enough speed, enough kinetic energy, to crest that ridge, it'll keep bouncing away forever. This is exactly what's happening with your log and the surrounding air. Carbon atoms and oxygen molecules are colliding constantly. Millions, billions of impacts every single second. They're bumping into each other right now, but they're not reacting. Why? Because they lack sufficient energy to overcome that barrier. They collide, they bounce apart, they separate. Again and again and again. The wood remains wood, the oxygen remains oxygen. Nothing transforms. This can persist for centuries. A wooden beam can sit exposed to oxygen for 1,000 years with zero reaction. The atoms desperately want to bond. They're energetically favorable to bond, but they cannot surpass that activation threshold. They're trapped in what scientists call a metastable state. Stable for now, but not in their ideal configuration. Like a boulder perched on a hilltop, waiting for a push. But then something changes. You introduce heat, a match, a spark, an ember. Suddenly you're accelerating a few atoms, making them jiggle faster. Their collisions become more violent, more energetic. A few carbon and oxygen atoms finally possess enough kinetic energy to overcome that barrier. They get close enough, and they snap together. When they bond, they release energy, a significant amount of energy. That released energy makes nearby atoms jiggle even faster. Those atoms now have enough energy to climb over the barrier. They collide with other carbon atoms, they bond. They release more energy. That energy accelerates more atoms. Those atoms bond, release energy. One reaction triggers 2, 2 trigger 4, 4 trigger 8, 16, 32, 64. This is exponential growth, a runaway chain reaction. Within fractions of a second, billions of atoms are bonding simultaneously. That catastrophic cascade? That self-perpetuating atomic frenzy? That's fire. It's not a gradual process. It's explosive because it's a positive feedback loop. Each reaction fuels the next, which fuels the next, faster and faster. All this frantic atomic activity generates what we perceive as heat. But here's something crucial. Heat is not a substance. It's not a mysterious fluid flowing from hot objects to cold ones. Heat is simply atomic motion. The faster atoms vibrate and jiggle, the higher the temperature. When fire releases energy during those carbon-oxygen bonds forming, that energy transforms into kinetic energy, atoms moving faster. That's heat. That's temperature. That's what you sense when you extend your hand toward flames. You're feeling atoms jiggling at incredible speeds. Fire itself isn't a thing, it's a process. It's this runaway cascade where atoms bond increasingly rapidly, releasing energy that makes other atoms move faster, which causes more atoms to bond. It feeds itself. The heat from reactions provides the energy for additional reactions. That's why fire spreads. That's why it's challenging to extinguish. Heat makes atoms jiggle fast enough to react. Reactions produce more heat. More heat triggers more reactions. Around and around. The only way to stop it? Break the cycle. Cool it below the threshold. Remove the fuel. Eliminate the oxygen. Cut one leg of the triangle, and the entire process collapses. Now, here's where it gets truly mind-bending. If you pause and think, and this is what happens when you start genuinely thinking, you keep asking questions. Where did this fuel come from? This log was once part of a living tree, and trees are mostly carbon. Where did all that carbon originate? Everyone assumes trees grow from the ground. You plant a seed in soil, the tree grows tall and massive. Obviously, it extracted that mass from the earth, right? Wrong. Completely wrong. This is perhaps the most beautiful misconception in all of nature. The carbon in trees comes from the air, from carbon dioxide gas. The tree literally pulls carbon dioxide out of the atmosphere, separates the carbon from the oxygen, keeps the carbon to build its structure, and releases the oxygen back into the air. The water? Yes, that comes through the roots from the ground. But where did that water originate? Rain, which fell from the sky, which evaporated from the surface. The minerals, the tiny fraction that becomes ash when you burn wood, those come from soil. But the wood itself, the bulk of the tree, that's carbon from air and hydrogen from water. Let me prove it. Take a pot of soil and weigh it precisely. Plant a seed, water it for years. Let the tree grow substantial and heavy. Now excavate the tree and weigh the soil again. The soil weighs almost exactly what it did initially, maybe slightly less. A few minerals got absorbed. But the tree now weighs hundreds of pounds more than it did as a seed. Where did all that mass materialize from? Not the soil. The soil didn't lose hundreds of pounds, it came from the atmosphere. This experiment was actually conducted. A Dutch scientist named Jan Baptist van Helmont performed it in the 1600s. He weighed everything meticulously. The soil barely changed mass. The tree gained enormous mass. He correctly concluded the tree didn't come from soil, though he mistakenly thought it came entirely from water. He was close. Water is part of it. But the majority of mass is carbon extracted directly from atmospheric carbon dioxide. But wait, I just told you that carbon and oxygen bond together extremely tightly, releasing substantial energy. So how does a tree, which isn't particularly smart, manage to take carbon dioxide, where carbon and oxygen are nicely combined, and tear them apart? Does life possess some mysterious force? Some vital energy unknown to physics? No. The sun is shining. Sunlight streams down and provides the energy needed to break those bonds, to knock oxygen away from carbon. Photosynthesis requires sunlight to function. The sun is constantly performing work, real physical work, pumping energy into the system. Trees use that energy to separate oxygen from carbon. The oxygen is essentially waste. They expel it back into the atmosphere. The carbon gets combined with hydrogen from water to construct the tree's structure. This is what makes life on Earth possible. The sun does work. It pushes systems away from equilibrium, creates order from disorder, builds structure. Trees are perpetually doing this, absorbing carbon dioxide, tearing it apart, constructing themselves from carbon, releasing oxygen back to the atmosphere. That's photosynthesis. The tree is using sunlight to reverse what fire does. Fire takes carbon and oxygen and snaps them together, releasing energy. Trees take carbon dioxide and rip it apart, storing energy. The tree uses sunlight to perform work, to accumulate energy, to build structure. And that structure represents potential energy. The carbon and oxygen are held separated. They're attracted to each other, but they're apart. Energy is stored in that separation. Then when we take that tree's substance and place it in a fireplace, surrounded by all that oxygen the trees produced, the carbon and oxygen would much prefer to reunite. Once you provide enough heat to initiate the reaction, it continues and generates tremendous activity as they recombine. All that beautiful light and heat emerges. Everything is being undone. You're converting carbon and oxygen back into carbon dioxide. And the light and heat pouring out? That's the sunlight that went in. Fire is stored sunlight being released. Think about that for a moment. The tree spent years, decades, perhaps centuries collecting sunlight, photon by photon, particle by particle, using that energy to extract carbon from air and construct itself. It stored that solar energy in its molecular structure. Then you fell the tree, let the wood dry, stack it in your fireplace, and when you ignite it, all that accumulated sunlight comes flooding back out. The carbon the tree laboriously separated from oxygen is collapsing back together. The energy that was stored is being liberated. Fire is simply stored sunlight escaping. A burning log in your fireplace is the sun shining again. Light that fell on leaves 5 years ago, 10 years ago, 50 years ago, captured in chemical bonds, released all at once. Every photon flickering in those flames is, in a genuine sense, a recycled photon from the sun. The energy is identical. It entered as sunlight, got stored as structure, and emerges as firelight. You might wonder, why doesn't wood spontaneously ignite? If carbon and oxygen are so desperate to bond, why do you need a match? Because of that energy hill, the activation barrier. At room temperature, atoms aren't jiggling fast enough to surmount it. They're colliding constantly, but they're not reacting. Wood and oxygen exist in a metastable state. They want to react, energetically prefer to react, but they cannot initiate without help. It's precisely like that boulder balanced atop a hill. It wants to roll down, that's the lower energy state. But it's sitting in a slight depression at the summit. It's stable as long as nothing disturbs it. Give it a small nudge though, and it rolls down, releasing considerable energy. That's what the match provides, the nudge. It heats a small region of wood, making those atoms jiggle faster, getting them over the activation barrier. Once a few reactions commence, they produce sufficient heat to trigger more reactions, and the fire spreads. This is why objects don't spontaneously combust. The universe is filled with metastable states, systems wanting to release energy but unable to start. Wood and oxygen, gasoline and air, food and oxygen in your cells, they're all waiting for a trigger. And once they start, they're self-sustaining. Here's another revelation that should astonish you. The oxygen in our atmosphere, where did it come from? From trees, from plants, from photosynthesis. For billions of years, plants have been splitting carbon dioxide molecules, retaining the carbon, expelling the oxygen. All the oxygen you're breathing right now, all the oxygen in Earth's atmosphere, it's waste. It's a byproduct. Plants don't want it, they discard it. Early Earth had almost no free oxygen. The atmosphere was carbon dioxide, nitrogen, water vapor, trace gases. Then photosynthetic organisms evolved. They began dumping oxygen into the atmosphere as waste. For many of them, oxygen was actually toxic. Numerous early organisms died when oxygen levels increased. But some organisms evolved to exploit that oxygen, to burn fuel with it, to extract energy from it. And that atmospheric oxygen is what makes fire possible. Here's the complete cycle. The sun shines. Plants use that sunlight to dismantle carbon dioxide, building themselves from carbon and releasing oxygen. Animals, including you, consume the plants, or consume other animals that consumed plants. And you burn that carbon, combining it back with oxygen to release energy. That burning occurs inside your cells. It's called cellular respiration. It's the identical process as fire, just slower and more controlled. You're taking carbon-based molecules and combining them with oxygen to release energy. The carbon dioxide you exhale is the same carbon dioxide plants absorbed. It's a cycle. Sun to plants to animals and back. Carbon circulating, oxygen circulating, energy flowing. Fire is simply that cycle accelerated and visible. When you burn wood in a fireplace, you're doing exactly what your cells do when they burn glucose. Same reaction. Carbon plus oxygen yields carbon dioxide and releases energy. The only difference is speed and control. Your cells do it slowly, carefully, capturing energy in useful molecules like ATP. Fire does it all at once, releasing energy as heat and light. But it's the same chemistry, the same fundamental process. You are, in a very real sense, a slow fire, a controlled burn. Your metabolism is combustion, occurring molecule by molecule, carefully regulated by enzymes, with the energy captured and used, instead of simply dissipating as heat. Let me make this even more concrete. When you burn wood, you're converting chemical potential energy into thermal energy and electromagnetic radiation. The chemical energy was stored in the molecular bonds holding the wood together. Those bonds required energy to create. That was the sunlight the tree absorbed. Breaking those bonds and forming new bonds, carbon dioxide and water, releases that energy. The heat you feel? That's atoms jiggling faster because energy was released. The light you see? That's atoms and molecules becoming excited, literally electrons jumping to higher energy levels, then falling back down, emitting photons. When carbon and oxygen snap together, the released energy doesn't vanish. It transforms into motion, atoms moving faster, molecules vibrating, electrons jumping to higher orbits. When those electrons drop back down, they emit light. That's the glow. That's the flame. Different atoms emit different colors. Sodium produces yellow. Copper produces green. Strontium produces red. That's how fireworks function. Different chemicals burn with different colors because they have different electron configurations. The smoke? Tiny carbon particles and other incompletely reacted material floating upward because they're hot and less dense than surrounding air. The ash? Those are minerals, the components that weren't carbon, the small fraction that came from soil. Everything else, the carbon, the hydrogen, the oxygen, has transformed into gas. Carbon dioxide and water vapor, invisible products drifting away. The mass didn't disappear. It converted to gas and dispersed. Now you should be asking, if fire is released sunlight, if trees are capturing solar energy, then how is the sun so energetic? How is it so hot in the first place? That's a different story entirely. A story about nuclear fusion, about hydrogen atoms being crushed together under unimaginable pressure and temperature, forming helium and releasing energy. A story about matter converting directly into energy, according to Einstein's famous equation. A story about why stars shine and why we exist at all. But I have to stop somewhere. I'll leave you something to imagine, something to wonder about, because that's what thinking is. Asking one question, finding an answer, and discovering 10 new questions waiting behind it. Fire isn't just fire. It's the universe revealing itself. It's chemistry and physics and biology all woven together. It's stored sunlight. It's you. It's everything.